don't see in the screen in front of me. Even I cannot open my YouTube.
Just the logotype of Linnaeus shown on the screen.
Okay. Yeah, I think now it's fine. But the screen is not showing.
Yeah, now you can see.
Okay, it's not. The mixed is not working, so they will not maybe see me. Yeah, now it's fine, I think. So, good morning, everyone. There was some technical issues with the system. So, in the previous two lectures, so you can follow the YouTube, right? It's streaming. So, in the previous two lectures, we looked at some basic theory about requirements engineering, and in particular, requirements elicitation, requirements analysis, requirements validation, and also requirements management. And the next two lectures, so today and the day after tomorrow on Friday, we will work with some tools, and in particular, today we will work with UML modeling and also the validation of UML modeling, how we can do that using some tools. And in the next lecture, we will look at how we can extract or generate requirements from various use case scenarios. And in particular, the security requirements, because security is also a vital concern for today's application. And the first part of the lecture will be today about basically giving some introduction on the UML. I guess all of you already have at least one course on the UML, but I will, for the sake of the second part of the course, I will briefly and quickly go over the UML concepts and some introduction on the UML. So, UML. Many of us have this wrong perception that UML is a modeling tool. It's not basically a modeling tool, it's a language itself by itself. So, we can draw diagrams, but basically we are not doing any modeling in UML. You can do modeling, that is called meta model, but what we are actually doing, using all the notations, all the representations, we are drawing the diagrams. So, it's more a graphical language or more a language or notational language in other words, that you can express your requirements to all level of users or to all level of stakeholders, depending on of course which diagram you are using. And in general, it shows the classes, attributes, what are those classes are doing, and what are the various relationships between the classes. UML was proposed by OMG. OMG is an open standard or open group, so anybody or anyone can join the this OMG initiative. And as a stakeholder of the OMG itself, end users also part of this initiative, and what they do, they basically provide standards for modeling or describing your requirements using graphical notations. So, they are the sole initiator of the UML modeling language. So, there are many versions of the UML, and I think the latest version is 2.5, 5.2, or maybe 1 is the latest one, and it started almost 20 years ago. more than 20 years ago. There are many diagrams in the UML, and obviously we worked with some of them, like class diagram or activity diagram or even sequence diagram, let's say. But in general, people don't use all of them. We will also work with today with the class diagram, but before also working with the class diagram, I will also briefly introduce all of them, maybe if not all of them, maybe some of them. But this is the taxonomy of the diagrams in the UML. So basically, from all the diagrams, they are classified structure and behavioral. So basically, some of them model the static part of the requirements, and some of them model the dynamic part of the requirements. So the static parts are known commonly as a structure diagram, and the dynamic part or the diagrams that model the dynamic part are more known as a behavior diagram. For example, the interaction diagram is the most common one, where we have also other types of interaction diagram like sequence diagram, timing diagram, or even communication diagram. And from the static part, the most common one are the class diagram. We also use sometimes object diagram, but there is a slight difference between them. But then we also have a component diagram, which shows more higher level representation of the class diagram. And you already know all of the diagrams, right? At least introduce, all of them. So I will briefly go some of the diagrams just to give a refresh. And the class diagram is the most basic one, so that basically provides the elements or entities in the domain, or sometimes those classes represents your data types in your system, where what you can model. And they not only provide or introduce themselves as a data type, but they also define the relationships between those data types. For example, here customer is one of the data types here, then order, stock, and product. So we can also see that one customer might have multiple order, and order basically involves many products, and also products need some stock. So these are the relationships that we can also find through the class diagram. Then the object diagram. Object diagram is basically nothing but the representation of or the instantiation of the class diagram. So here we don't have any multiplicities or any numbers. We have simply the objects. So if we say that customer might have multiple order, in the object diagram we specifically say or see that it has 3 orders. Then the sequence diagram. So sequence diagram is a little bit different than the class diagram and object diagram, but it also has objects. But the main difference between object diagram and sequence diagram is that it cares about the lifeline of the objects, and also the sequence of the messages they are passing through each other. And whenever the messaging sequence finished, that means the lifeline of the object is finished and we don't need that object anymore. So it's more concerned about the order of the events or order of the messages. Then we have communication diagram. This is also similar to the sequence diagram, but it is different in other sense that it doesn't care about the order of the messages, but all it does is highlight or deeply analyze the messages. So it's focused on the messages, but it doesn't care about the order of the messages. So what are the messages various stakeholders or various users are passing through each other, instead of thinking about the order or the sequence of the messages. Then we also have component diagram. This is a little bit higher level than the class diagram. So basically components are a collection of classes. So multiple classes form a component. So a component can also implement one specific feature or one specific requirement, which you can break down, like multiple classes can be involved or implemented to implement a requirement. So each component basically have their own interface through which other component can invoke them or use them. So by default, a class might not have an interface, but a component will always have interface because it's more higher level, and there is a much possibility that someone will need this component or this feature implemented by this component. Then we also have deployment diagram. Deployment diagram is nothing, basically gives you all the deployment details. In particular, if you have a web server, you have a database server, you have an application server, how they will be deployed and how they will talk to each other. So they also focus on different communication protocols, host environment, and so on. As you can see here, the web server is talking to application server through RMI, and then we also have JDBC between database server and application server, and so on. Then we also have activity diagram. This is one of the very simple diagram that people use, or in a simplest form. Basically, it identify all the high-level activity, and you don't care about basically what is the outcome or what is the exception or what is the input of the activity. Rather, you identify the high-level activities and the sequence of those activities. For example, business processes, they are designed through activity diagram. And then the interaction overview diagram. Interaction overview diagram is also a little bit higher level than the activity diagram. So here what you have, basically you have multiple activity diagram, and then you show how those multiple activity diagrams interact with each other, and that's interaction. So this gives you more high-level picture than the activity diagram. Of course, you have only one start and one end. But also in the sequenced activity diagram, you have one start and one end, but this is more of a high-level picture than the activity diagram. Then we have package diagram, where it shows dependencies between packages. So those are simple package in Java, for example. And if we have multiple package in the Java, there is of course always dependencies between packages through what you import the packages, or you use the classes from other packages, and so on. The state machine diagram is also common, but it's not really used for requirements engineering or requirements management. Basically, it shows the state of the object and how or why they jump from one state to another state. So it implies the conditions, and based on the conditions, it jumps from one state to another state. For example, from here, if you are in the win state as a player, you can only go to losing state if you lose. So if you keep winning, you cannot basically go here. Either you have to finish or you have to stay in this state, and same for the lose state. The timing diagram, it also shows what are the timing between the activities in your software or in your application. And by doing this, you can also get an idea about the latency, about the response time, about the availability, and so on. So it is more about non-functional requirements. For example, as a user, I can type a URL in my browser. Browser will talk to the DNS server. DNS server will resolve the address. Then it will talk to the application server or database server. So all these are having some time, and once you get the data, you create the HTML page that will be rendered. So it also takes some time, this rendering or this HTML creation. And once you get the response, it will also take some time to display on the browser. So all this timing intervals, they should be also considered, and which should be minimized when you are trying to achieve some non-functional requirements or modeling some non-functional requirements. So timing diagram is about timing constraints. And then the use case diagram, this is also very common diagram among the developers and also end users, because this is the diagram that end users understand most, and they simply identify this use case diagram. It simply identifies different users and how they talk to each other and how they talk to different use cases of the system or features to the of the system. So UML Basics, again, as I mentioned before, it's about interrelated set of information, or classes, or actors, in other words. And a diagram is only one view of understanding the domain, or understanding the problem, or even the solution. And we do that by basically doing the UML modeling. But what is the difference between model and diagram? That can be one interesting question, not only for the engineers, but maybe also for you. Do you know what's the difference between model and diagram? We sometimes maybe interchangeably use them, but they are not really the same. So when we call something UML model and when we call something UML diagram, should we say the same name for them?
Isn't it in the conceptual stage of the development, so you think about models instead of actual diagrams of abstractions that you do?
Yeah.
Classes and
Yeah, this can be one possible answer, but I wanted basically a more specific answer. But this is kind of the idea that you wanted to. This is kind of correct, but I wanted to have more specific answer. So basically, diagram. So you can have a model. So let's say you can model this classroom, but then it will always have two doors. It will always have one lecture board. It will always have one computer. But then it's up to you how we want to represent that model using different diagrams. So for example, you modeled this room using two doors, and you made a diagram for this model, and you deleted one door from the diagram, but that two doors will still remain in the model. But if you model this room with two doors, and then you draw the diagram, that will also obviously have two doors, but you deleted one door from the model, that door will automatically deleted from the diagram as well. So that's the main conceptual difference. So if you change the diagram, it will not affect the model, but if you change the model, it will affect obviously the diagram. And we should be careful also when you are modeling. Are you doing the modeling, or are you doing the or making the diagram simple? So UML diagrams, for example, class diagrams, those are simple diagrams. But if you are talking about model, that means you have to have a meta model from which you are having a model instance that is representable using some diagrams. So there are 5 basic concepts in the UML diagrams: classes, associations, attributes, operations, generalizations. I guess you already know all of them. I should not go for each of them. And these are very basics for the UML diagram. In terms of model, as I said, there are 2 types of model. So one is exploratory domain models, and one is system domain models. So exploratory domain models are basically for end users, for non-technical persons, so that they can easily understand that. So we have to draw the exploratory models in that way. And then we have the system domain models. Basically, this is more technical. For example, the deployment diagram, it cannot be targeted for the end users or the non-technical persons. So those are more about system or more in detail. So they talk about more about low-level requirements. So those are example of system domain models. Of course, class diagrams are also system domain models, but then it should be handled automatically, not like manually. Then what is the step or suggested steps for requirements modeling? And also for this assignment 1, or this part of the assignment, I guess you need to have some sorts of modeling. and I will suggest that you will also follow these steps, else it will have some modeling issues at the end that you will find that are missing. So the first one, or for the first step, is identify the sets of candidate classes, and it can be anything that comes into your picture if you are thinking about requirement. So basically you will start with a requirement, and then what are the possible classes or possible actors or possible data that you can have based on the requirement. And once you have all the classes or possible actors, you should also identify, basically you should start the most important ones, and maybe you can ignore the least important ones, because not all of them will be implemented in the first step. So you start with the most important ones or most common ones, and find the relationships between them, as well as what are their common attributes or common properties that is possible they might have. And then if you have multiple classes or multiple actors in your system, there is always possibility that you can generalize them or you can group them, and that is known as generalization. So try to work out on the generalization of your classes or of your actors, so that you can have, for example, one interface that that will be implemented by all of those actors or by all those classes. So this is the goal of having the generalizations, and generalization are usually represented hierarchical manner in UML. So once you have the classes, you have the attributes or associations and their classifications or generalization. Now come to the responsibilities. So what are the what could be the responsibilities for those actors or for those classes given the requirement? And these responsibilities should be clear and exhaustive, because if you miss any of the responsibilities, you will miss some important operations that might be required by that classes or by that actors. So what we do in general or in practice, we arbitrarily come up with a class. We start right away with the attributes. We start right away with the operations. Basically, we miss this third and fourth step. That is also good practice for the UML modeling or any kind of modeling. So once you have the operations, that will be the responsibilities for the classes. You try to see if there are missing associations, because now you know the operations and the generalizations. So now you can maybe identify more associations, more attributes, and even more responsibilities. And you should basically refine or iterate through your 2, 3, and 4 steps until you are satisfied. But at this point, like at number 6, since this is the last step or last actionable step, you should also identify possible design patterns and interfaces, because here you are doing the generalization, and the goal of doing the generalizations is to have some interfaces, and design patterns will also help the developers, so that when they will implement those classes, they can follow this design pattern. And obviously there are benefits of design patterns in terms of maintenance and evolution, if you know some design patterns, right? So this identification of design patterns should be also a part of your modeling activities. And then finally, basically, as I said, repeat all the steps until you are satisfied, and it will eventually give you a very well-defined model or well-defined translation of your requirements into a modeling diagram using a language. So some more about UML Basics class. So we will now go through different construct of the UML Basics or UML diagram. So first of all, the classes. Classes can be of any detail. So you can have only a class name. That is not a good representation of classes. You can have classes with only the operations. you can have classes with the attributes or properties. You can also have classes both of them, but without representing any types or any accessor modifier. But then you can also have some complete and some incomplete properties. So basically those are all not good examples of UML modeling. What I suggest for your modeling also, when you are defining a UML diagram, try to have this full signature in terms of method and also in terms of properties or attributes. So always put the access modifier, operation name, both the parameter name and type, and also the return type. So in UML modeling, you might not need the parameter name because those are during the development, developer can provide. But if you want to, you can also provide those during your modeling. Then the associations and multiplicity, and these are also very basic. What all I want to show is basically you can have different types of associations or multiplicity, and most common ones are of course one-to-many, but there is also one-to-one or many-to-many relationships. But in general, one good practice is if you have one-to-one relationships, you can basically merge those two classes. It doesn't make sense to have so if I am Francis and I have an address, so my person class and my address class are different. It doesn't make sense to make the simplest to make the system more complex. Better you merge them two classes. And then labeling the associations, always try to use a verb or verb phrase. So these are good practices of modeling. So try to use a verb for labeling the association or showing the relationship between classes. And if you do not have any label for the association or relation, by default is always has. For example, one company is employ many employees, but many employees work for one company. And if you don't have any labels, for example here, it always has that means it's by default. But else, you should also basically place your role names or association names close to the object or class to which it more relates. So for example, if I put works for in the middle between the two classes, employees are working for the company, but company is not basically working for employees. So it doesn't make sense so much. But since here, as you can see, a person is a board member of a board of directors. So this board member is more applicable to person. So it was placed towards more towards person to make it visibly understandable. Also similarly, the supervisor. So this supervisor is not the administrative assistant. This is the manager. So it was placed more towards a manager. So these are very small good practices for modeling or for designing your UML diagram. Then analyzing. As I also mentioned, that there are mainly three kinds of associations. So one-to-many, many-to-many, and one-to-one. And as you can see, the order is one-to-many, many-to-many, and one-to-one, because one-to-many or many-to-one is the most common association. And then, of course, we have many-to-many, but one-to-one is rarely used, and it should not be used if possible at all. And I forgot to mention that it's very common to make errors when creating associations. So what's the reason you think because of this making error? So why it's so common? This is another simple mistake that the designers do, or maybe you will also do. So the thing is that when you are designing your UML model, or UML diagram. So I'm also sometimes using a model versus diagram. And what you are doing, you are most of the cases reading your relationships or associations from one end, but when you are doing your diagram, always validate by reading from the both end, so that if the relationships make sense, and also so that the multiplicity or the numbers make sense. So that's why it also makes the developer's life harder if you have confusing or conflicting associations in your diagram. And also, I think I already mentioned it, if you have one-to-one association, you should always merge them to make it more less complex. There can be further complex relationship, like one passenger might have multiple booking and one flight have also multiple booking. Then the association classes. There are some associations or some relations that are not always possible to express through verb or verb phrase. You can express them, but sometimes they are more complex. So the good practice is, for example, students might register in the course, and in this case, registration or register is not only relation, but it can be further broken down. So it itself can be a class, because students have their information, have their own information, classes have their own information, but registration can also have some information that they can hold. And example is, if you have a registration that has all the grades for courses taken by the students, and then we can translate this association class in this way, like one student have multiple registrations, and those registration has some grades, and also the course section or the course module has many registrations. So each course, for example, software design, have multiple registration, and each of the registration will have also one grade. So basically what I wanted to say, that sometimes you can express complex relationships or complex association through a class, and this class is known commonly as association classes, and it's also a good practice to have association classes. And for association class, you should always use a name instead of before it was a verb, and that is another transformation. Check for many-to-many associations if you can replace with an association class, and this this can be done for basically mainly many-to-many relationships, because many-to-many relationships are flexible, but what they does, they increase the they are less complex in terms of diagram, but what they does, they are less flexible for the design and implementation, because we don't know how many students will be there, and we don't know how many course section will be there. So it can be a mess when you have hundreds of students and hundreds of course. So the good way to model this kind of relationships is to have only one student, so one student class. So you will have only one instance of the student class. You will also have only one course object. Then you can have multiple registration or multiple registration object, and this is very flexible in terms of design. Reflexive associations. So associations are not only between classes or between objects. It can be also within the classes, or for a specific or single object or single class. And there are two types of reflexive associations: asymmetric and symmetric. So in the asymmetric association, as you can see, it has different roles in each end, and for the symmetric relationships, it only has one relations or one roles. So courses can be prerequisite of other courses, and if you are doing some prerequisite course, that means you can take some certain successor course. So there is this two different relationships between the courses that you can also express for one class. and then there are courses that are mutually exclusive. So it doesn't think about successor or prerequisite. It always think about if the courses are independent of each other or not. So you can specify this kind of reflexive associations in the UML model. And what it says, instead of association name, try to have role names when you are reflexive associations, having reflexive associations in your diagram. So those are basically roles, prerequisite and successor, and those are not association name. So directionality in the association. So association by default are always bidirectional, but it's also good or maybe better to have directions in your association. It will it's more clearly specify the relationship between objects, and also it reduces the complexity and improve the efficiency of the modeling. And the generalization, I think we also talked about a little bit about generalization in the modeling steps, and it's about classifying or aggregating your classes or objects according to their nature. And if you want to, for example, have 3 different accounts, savings account, checking account, mortgage account, you can of course generalize them to an account. So this account can be an interface, and this savings account, checking account, and mortgage account might have different properties and attributes or operations, and they can all implement this account interface. For example, from savings account you cannot withdraw, but from checking account you can withdraw and deposit both. And this kind of relationships is known as inheritance hierarchy. So this savings accounts is inheriting some of the properties from account, but it also is implementing its own properties. So difference between association and generalization. The main difference is that association only exists between instances. So if you have if you have association between 2 objects, and you say that one object can have maximum 2 instances, so in the runtime or during the instantiation time, you will have 2 objects of the right hand side, that we say that we might have maximum 2, and you have 1 objects of the left hand side object. So basically it doesn't have any numbers in the object diagram or in the instances, but association have number in the UML diagrams. But the generalization, this can be always in the class diagram. This cannot be in the object diagram, for example, and that's the basic difference. So generalization applies to the class diagram, and association applies to the object diagram. Of course, you have numbers in the class diagram, then in the object diagram you reflect those numbers in particular or precisely. And that's being said, object diagram can never contain a generalization. It always have numbers that were mentioned in the UML classes, or associations that were mentioned in the UML diagrams. The aggregation, it's also another important aspect of UML diagram. So those are also common. I think also very basic. So you basically have part, whole, or part of relationships. So one vehicle might have multiple, or will have multiple vehicle part. One country might have multiple region. One building might have multiple room. So this is very simple aggregation. But then we also have composition, which is more strong aggregation. And the difference between composition and aggregation is that when you destroy the vehicle, or when you break the country, the regions or the vehicle parts are still there, so those will not be removed or not go away. But when you destroy the building, so this is the composition, all your rooms will be destroyed, so the room will not exist. So that's why it's more strong constraint or a strong relationship than the aggregation. So composition is basically a strong aggregation. this is the same example that I said. And also a one-to-one composition. So this composition, so the employee, it might have name or address, not address, age or other things, and it's related to address. So this is a also another class that has different address information. So what we can do, if we have this kind of one-to-one relationship between the composition, we can merge into one class as a compound data type, for example. So the address data type was a class that we made a compound property now, or compound attribute, and this also makes the life of the developer much easy, as well as the modeler or the designer who is modeling the UML diagram makes easy. Also, the people who will be reading this model or looking at this model will be easy to understand that this address might have multiple information. So we can represent in this way, simple way. Interfaces, this is also a very common thing, also not only in the implementation but also in modeling, and this is also related to the generalization. And you can have basically a generalization of a person, like multiple employees or multiple other stakeholders can be a person. So in this case, in this example, both the employee and the ATM are the cashier, because both of them are giving you money, and both of them are you can also deposit money to both of them. In fact, employee is a type of a person, but ATM is a type of machine, but they are implementing both this interface. And this is the benefit of having an interface, that it gives you some common behavior that other people can expose or you can use. There is of course a fine-grained difference between generalization and interface, because interface is a relation that defines can be seen as, but generalization is defined as is a. So employee is a generalized version of person. So an employee is a person and ATM is a machine, but both the employee and the ATM can be seen as a cashier. So that's the fine-grained difference between generalization and interface, even though they are sometimes implemented in the same manner in Java, for example. So describing the UML, we were talking about basics of the UML, but not all people or not everyone understand the UML in the same way, or it is not always possible to describe your UML so that you yourself know that the UML modeling was correct or well represented. So in doing that, you can do in 3 different ways. One is to describe your UML in a very high level language that is good for non-technical people, people who are outside of your organization. And then there are other ways, like I think UML has these benefits, like you can add simple nodes that can say that what it's class about or what is the class doing. And then finally there are more technical way of describing your UML. So in this way, you are not only describing your UML, but you are also checking if your UML modeling or your UML diagram was syntactically and semantically correct or not. And in the second part of this lecture, we will basically go through an example of how we can do that. So example shows here, for example, we have a linear shape, and one linear shape might have many other lines. A linear shape can be of different shapes, like polygon, only line, or a path. This is a simple class diagram, and polygon can be a rectangular. So one way of defining this class is to talk about simply about this class in a note using high level language, but the problem is that it increased the complexity or the design complexity of your UML. There are other ways. For example, for this class line segment, so it's a simple line. It has two properties, start point and end point, and it also has a length. So if you want to check if it was well implemented or well defined as a class in the context of line, we can check that when we are assigning the values to this start point and end point, we can check if the start point is not equal to the same point end point or not. So if they are not equal, usually if the start point and end point are equal, that means it's dot, it's not a line. So one very basic check for this class is that the start point is not equal to the end point. For example, another thing is here. So for the line, the edge of the size, so the how thick is the line is 1. So if it's more thicker than 1 point or 1 dot, it can be even a black rectangular, for example. So what I wanted to say, that line is always very thin, maybe 1 point. So if it's more than 1 point, it may not be a line. For the polygon, for example, if we think this one as a polygon, so when we draw the polygon, we start from a point, right? Let's say we started this from this point and we are drawing this polygon in this way. That means the start point and the end point of the polygon is the same. So this is another check to see if it's a polygon or not. So in this way, you can basically add many constraints or criteria to check not only your email at the design time, but also at the runtime when the developers are implementing those classes, or they might also generate code directly from your model. So do you know Ecor, or have you worked with Ecor before? Then it could be an interesting exercise for you after in the second module. So Ecor is it's not new, it's kind of old. It's a good modeling tool under the EMF, Eclipse Modeling Framework, and it gives you the possibility of having the UML diagram as well as generating the code from your UML diagram. And once you have the UML diagram, you can put some constraint on the UML diagram that will be validated runtime, or when you generate your class instances, or when you generate the instance model of your main model. And benefit of having Ecor is that it has all the corresponding representations of Java interfaces or Java members. For example, for Java package, it also has an E package. For Java class, it has E class. For attributes, it has E attribute. And the references between classes, it also has E references. So whatever you design, it will be automatically translated or mapped to the Java technology, and in that way your code generation becomes very easy and straightforward. And talking about that constraint language or checking your UML, we will use OCL. So have you ever anyone used OCL? This is also a constraint language. So this was developed by IBM, that you can directly apply on your UML model to see if your UML model was correct or validate, or if it will create any problem when you instantiate your model. And I think in the next phase of the lecture, it will be a very good exercise, and maybe you will know something interesting. And it's not a programming language. It's more about scripting language, and it evaluate the model instances immediately. Like that's why it's instantiates. And some of the constraint, for example, you defined a association or you defined a aggregation. you can define on UML diagram anything, but then there is no way to know that the relationship you defined is actually valid or not. And that's another way of using or another benefit of using OCL, like you can instantly validate your UML diagrams. And I think this is the last slide before the break, but then we will start with the hands-on. So using the OCL, you can access to the role names, to the association names, to the attributes, or the operations of the object itself. So it gives you access to all the components of the UML diagram. If you are writing expression using OCL, it should be always true for your model to validate or to correct. You can have all these operations in your OCL expressions and all those equivalent comparators. You can also have constant or string values for comparison. You can also do some mathematical operations using your OCL expressions. And by the way, OCL is object constraint language. So it's a language that checks for the constraint in the objects. So there is some quick examples before maybe we stop. And here is a simple class called person. It has a flag called student to check if it's a student or not. It has a name, it has age. So name is the string, age is the integer, and it has this operation. So if we call this operation, it will show all the details of the user. It says that one person can have one partner or even zero partner, and also if this person is a child, it can have 0 to 2 parents. So this is this relationship is known as family. And if this is the given class or given object we have, so how we can check if the class or object was well implemented or well designed? So one of the case is, for example, the name of the person should be always using alphabetical characters. It should not have any other. It should not have digits. It should not have other punctuations. To do that, we can simply write a constraint on this object in this way. So this was written in Eclipse, but it's also written here. So self. So when you write self, that means it's defining the object we are currently at. So this is the self, same as Java self. Then dot name. So when you put the dot, it gives you all the name of the attributes and also the operations. So we get the attribute name dot, and when you put the dot again, it gives you all the operation names that is applicable to on this attribute. For example, it was a string attribute. So now we have this matches operation. This is a command from OCL which has this parameter. So with this parameter, we can say that this is the regular expression, and that name must matches between A to Z and capital A to Z. So this is one constraint. Then we can also check that a person is not a partner of itself. So we can say that a person has a partner, but a person cannot be partner of itself. How we can express that? So self again. So self means this object dot partner. So the partner of this object is another person, not this person. So then we can say that not equals to self. So if it were another person, it could be self dot partner A or partner B, let's say. We want to also check if the age is always greater than 0, because the age cannot be negative. So in this way we can do that. Self dot age is greater than 0. We can also check if the person is a student, and he can be only a student if his age is greater than 8, let's say. So in that case, we want to check if the self.student, so student is the Boolean operator, equals to true, and his age is greater than 8. So these are the 3 simple examples. So there is one complex example. So we want to check that each child should have at least 2 parents, because without 2 partners a child cannot born. So how we can do that? Let's say again self. So this is denoting this object dot children. So this there can be one children might have 2 to 0 parents, which says, so if we have self dot children, it will get all the children it has. So I don't know how many instances we can create of this person object. So let's say we have 3 children, and for all the 3 children, what we are doing, we are iterating over those 3 children. So we are assigning each children to this variable, child variable, such that the child, so this child means, again, this is the same object, but it can be a different person object, not this self. So this self object and this child object is not the same here. So what we are doing, whatever number of children we got here, we are iterating over each of them by assigning a value to this child variable, and we are checking that the number of parents, so child dot parents, and then this is the size method in the OCL. So the number of parents is always 2, and if this is true, it will be true for one case. For everything to be true, it has to be true for all the 3 children that we assume that we have 3 children. So if this is true for all the 3 children, then this value will be true, or the whole expression will be true. And for OCL, as I mentioned, it to be true, the expression should be always evaluated to true. So it cannot be false. If it's false, that means your model has a problem. So that we will do after the break. So we will install EMF and Ecore, and we will also install the OCL. And I guess you have your laptop and your Eclipse with you. And after the break, we will do this hands-on. So let's go back to the lecture. So did you get the slides from my Moodle? Because some of the code that we want to write are on the slides. So maybe you can, if you can get the slides, we can directly copy paste from the slides those code. Else you need to write a number of lines. So I don't want to spend time writing all those. So maybe try to get the slides from my Moodle, and then we start. Okay, so the first thing, because I will also use the slides, so I moved my slides here. And then I can make the screen bigger. Okay, so basically what we'll do, we will install the OCL, and then we will use an editor where we can write constraint on the UML model that we will have, and we will also enrich the model with some utility functions, and then we will validate those constraint and utility functions. Let's so the first step is to install the OCL. Which versions of Eclipse you have? Mars or later versions? I think I have here Mars maybe.
September.
And maybe if you want, you can also have this, the modeling version of Eclipse. So which you have the which version, enterprise version or the standard version? So maybe, okay, so install new software, and then go to your update, or so do you have, everybody has this page? No, you don't have this page, like if yeah. So maybe you can also group together if you want. So you don't have this this page of all the applications that you can, or all the tools that you can install. Did you find this page? So yeah, it will come. Yeah. So from this page, basically you go to the modeling, and in the modeling you will see there is OCA examples and editors. You got that? So you go to your release download page, and then from modeling. So under modeling, you have this OCL examples and editors. This one. Did you found that? Okay. So just install it, yeah, and then restart your Eclipse. I hope guys on the Slack can also follow me. Okay, I'm just restarting my Eclipse. Someone said the slide is not my Moodle. Did you find the slide? Yes. So people from the class, they said they found the slides, and Jacob. Yeah, it's a modeling with UML. So everybody can install the OCL.
It's loading for me.
Okay. I want to make it quick as possible, because some might want to leave, some might want have other appointments, and we don't want to go beyond 12 also.
It seems like my internet connection is very slow, so it's probably going to take a while for me. So it's maybe better if you continue.
And then make sure that you are in the right context. So it doesn't show here. So you have to be in the modeling context, not in the Java context. So anyone installed OCL? Yes. Okay. Then I can. So did you install?
How do you get to the model?
Yeah, just here you have model and Java. Or if you don't have it here, my menu is not showing here. So you can go to window. I don't know why my menu is not showing. So you can go to window and then change the perspective. Open other perspective, and there you will find different perspective. Select the modeling one. You don't have modeling? So did you install OCL?
Yes. And did you reset? That's everything you have.
Check which Eclipse version you have. Is it?
I have an older one than you have.
Okay, you have the Java version. Sorry?
We had an older version of Eclipse than you.
Okay. Because this is only for Java development, not for modeling.
Okay.
So you have to install maybe the modeling version one, where you can not only model but also develop Java programs. Or maybe I will put this tutorial online. So maybe what you can do, you can simply, those if you could not install or have this modeling part, you can simply follow me, and I will put this tutorial online, so that then you can go step by step. So I will open this modeling perspective. So now what I will do, I will create a new project, and that project will be empty EMF project. Eclipse modeling. No. What did I do? This mouse. This mouse is has a problem. So I will go to Eclipse modeling framework, empty EMF project, and then I will give a name. Let's say library. So this project, this UML model is about library. So I'm giving the same name. So once you create the project, it has a source folder, basically all the source code. If you want to generate model code from the model, it will be there. But what folder we are more interested in, this model folder. So it will all the models will be placed here that we will create. So now what we will do, we will create a model, and the model will be a Ecore model, obviously. So you go to new, then other, and you go to OCL, and you select OCL in Ecore file, giving the file name of the model. Just for the sake of example, I am giving the same name. So it will be created under the model folder, and once you finish, you will see an example class is there. So this is a very typical form for OCL. So you have a class, you have a operation for the class, then the body of the class operations is defined. You have a attribute for the class, so name attribute, type of the string, and these properties are the relationships basically, or associations for that class. And this is the same example that maybe we discussed before, like they have a children, they have a parent, and so on, all those relationships. And this is the interesting part. So this invariant, these are the OCL invariants that will be checked or validated against our model. So this is the name of the invariant. The name should be in lowercase, and see how this is doing the checking. But we are not interested in this. What we will do, we simply close the model, and now I will introduce some of our own code, or we will introduce our own model. So for that one, so from the slide number 48, I guess, you copy the code of library, and to paste your code, you open your model. So this is the Ecore file or Ecore model. So to edit it, you need to use it, open it with no, not in Ecore model. OCL in Ecore editor. So there is two views. So the other view was the hierarchical view of your model. So if you go here, it's the example class that we have, and then the OCL constraint, the operation it has, the relationships, and also the attribute. But what we are interested in is in this view. So from slide 48, you simply paste your code here. So what it will have a class called library. It will have a class called book. It will have a class called member, and it will class called loan. And each of those class has their attributes and properties. So those properties are relationship with other classes. For example, this library class has relationship with books and loans and members, and so on. And this is the real type of the relationships, so composition. And I think there is error because we need to include the library for Ecore. So that one, I guess, was not in the slide. So for that one, if people are following me, you can write simple Ecore, like Java-like import for Ecore. So I'm also writing following my slides. import Ecore, and then the location of the Ecore library. Sorry. Eclipse.org /emf. I think that's why it was having problem. So it should one here, no, it should be one here and the other one at the end. So it should come up some suggestions now. EMF 2002 still did not come. Ecore page, and then I think this one, and then we also have a semicolon. So if I save it now, the error should go away. So what we did is we basically this date. So we had a class called loan, which has an attribute called date, and it says what was the date for that loan, and that's why the type of the date was, or data type of the date was edate, which was part of this Ecore specification, and we wanted to import this Ecore library for that one. I think that's the first code we want to have. And now what we want to do, we want to visualize this model. So initialize Ecore diagram. It will be in the in this format, AIRD. Simply go to next, and we want a class diagram, and we want to have diagram for this library. So we chose that library, and it will get this this diagram. And this is the same representation of the model we had. Maybe we can try to improve a bit the visualization so that we are on the same page. And then we also have this relationship between library and the book, and then we have this relationship. So this is the relationships that I already mentioned, like library can have multiple books, so 0 to many. Library might have multiple members also. Then each loan will have 0 to 1 book, and each loan will also have 0 to 1 member, and the library will also have multiple loans. So this is the very basic model that we will work on with. So anybody has any question before I move? What was the next slide? Yeah, I think that we covered. So anybody have any question, or are you following? Okay. So what we will do, right. Okay, where is my cursor here? So we will create an instance of this model, or this meta model. And to do that, we go to the Ecore model again. So we open with the editor, and we are creating the instance of the library. So this is the main class. So just right click on it and say create dynamic instance. So it will create a dynamic instance in XMI. So it will basically be serialized in XML. And once you create the model, it automatically opened, but we can also open it in other ways. So this was the instance of this model, so this XMI file. So we have to always open it using sample reflective Ecore model editor. And this was the instance of the library class that we had. So if you go, or if you right click on it, you will see it will have validate and live validation. So if you select the live validation, so whatever we will do on the model instance, it will check instantly, but for now we don't want it. We just want to validate manually. So if we validate it, it says it's successful, but it will obviously say successful because we don't have anything in the model. So what we want to do, we want to populate the model now. I guess that's the next step also in the slide. Yeah. So we want to populate the model by adding books, by adding loans, and by adding the members. So let's say we have 2 books, then we have 1 loan, and we have 3 members. So if you think of a object diagram, this is the object diagram of the class diagram that we had, and obviously you can set the properties for that each classes. So let's say the first book is book 1, and we have 1 copy. So as you can see, you cannot see here. I don't know why the screen is not showing. Yeah, it's showing here. So it says number format exception 0 length big integer. So this is a constraint imposed by the UML itself, but this is very general constraint. But what we want is more customized and advanced constraints. So let's say book 1 has 1 copy, and book 2 has, we can name it book 2, and it has 2 copy. Then we have different members. So let's say member 1, we are just naming them randomly, member 2, and then member 3. And let's say we also want to assign a loan. So let's say member 3 got got book 2. No, member 3 got book 2, and it can be today's date. Let's say February 05, 2020. It gets some weird format. So what we did, we populated the loan, we populated the book class, and also we populated the member class. So still now, if we validate, the model is still valid. So we can close the model again. And what's the next step? I guess so the next step is to add some constraint or some checking in this model. And to do that, so what we will do, we open the model again, this one, and we create 2 more loans. So we had only 1 loan that was of book 2 by member 3. So we can create two new loans, simply copy pasting that loan, copy and paste. And let's say the first one was book 2 by member 3, and the second one was also book 2 by member 3, and the third one was also book 2 by member 3. At this point, so I saved it, and at this point, if I validated the model, the validation is still successful, right? So the question is, should it be a valid model or invalid?
Invalid.
Why?
Because it was just two.
Yeah, right, yeah. So you're right, because we had 2 copies of the book 2, but as a developer or as a so the guy who is designing the model, he instantiated 3 copies of book 2 that we are not allowed. So to avoid doing that, or not allowing developers to do that, what we can do, we can change our book class by adding some invariants. So let's say we want to change this book class, and let me copy the slide again. So it's slide 52. If someone is following me online, that I am copying the code, and I will simply replace the code of the book class only, and in this book class I have this new invariant called sufficient copies that will check if I have sufficient copies. So as you can see, as soon as I saved this invariant, my model will have a problem. So basically it will this is the name of the invariant, sufficient copies. What it is doing, it's so since it has a relationship with the library, so it's getting the loans from the library, and for this book, so that's why the book itself, it's checking how many copies it has. So if the number of loans is less than or equal to the copies, then it's fine, else not. But I guess for our cases it was not the case. That's why if we now go back to our instance model and we validate it, it should fail. Yeah, it failed because it says sufficient copies constraint that we defined is not violated, is violated on book 2, because we had 2 copies of book 2, but we assigned 3 copies to member 3. So what we can do to resolve this problem before we actually instantiate the or generate the code, we simply change the booking to book 1, let's say, right? And as soon as we change the booking of first one to book 1, it should, and if we validate again, it should resolve the problem. So this is one way of validating your model using constraints, and I guess this error tag was for nothing, so sometimes it just behaves weird. And now the second part of this tutorial, that we want to enrich our model or our classes with some more utility functions, or let's say with basically we want to enrich our model. So what we can do, we can let me go to the slide. Yeah, I think that's the second part. But what we want to do is now we want to play with this model in some interactive way, and also we want to introduce some utility functions. To do that, basically you go to the console, and in your console there is something called interactive xtext OCL. So you go there and this interactive OCL has two parts. So the top part is the output part, and the bottom part is basically where you write your query. So what you can do, you can query on your model, or you can interactively check your model. And to do that, you have to select a particular context. So if you select this library, and when you are writing the query, it will show all the books, or all the information about the library. So for example, if I write, okay, did I put any name for the library? I guess not in our model. So in our in the library properties, yeah, we did not put any name. So we can give a name for it also, but others we gave the name. So for example, for library, if we check the books, it has 2 books. If we check the loans, it has 3 loans. And then if we also check 1, 2 members of the library, we can see that it has 3 members. But then what if we want to check each of those instances or classes in the model? For that one, we need to basically define our own customized constraint. And again, going back to the book class. So now we want to see, for example, we have 2 copies of the book 2 in loan. We have 1 copies of book 1 also in loan, and we want to see if any of our book is available or not, or if both the book 2 or book 1 is available or not, or how many copies of the book are in the loan. So for that one, and those are also known as feature functions or utility functions in OCL. So for that one, I am again copying the slide 55, and I am replacing this the book class also with my new code. So what it does, basically, we had this already attributes before. We have a new property called loans, and this loans is calculated in this method called operation is available. So what it is doing is checking if the number of loans that the book is in is less than the copies. So if it's not less than the copies, the total copies we have, that means the book is not available anymore. And also, yeah, this was the invariant that we had before. So for example, we want to test this is available method for this book, for any book, for example. So we have this new property, and also one thing I want to mention, this new property called loans, it is calculated in this method, but this property is derived. That's why it's coming from another part of the class, and it's also volatile. So whenever the class is loaded, since there is nothing or it's not calculated yet, the value of the loans from the previous calculation will be erased, and it will have by default 0 or no value. So now if we want to test this method, is available method, we go again to our model instance, and now we go to the book, because now we are testing that constraint on the book, and we can simply write is available, and it will say false because the book 1 had only one copy, and it was already in loan by this guy. I think it was here by member 3. And then if we also check this one for book 2, the same utility method, utility functions. For book 2, is it the spelling mistake? Available. So the book 2 is also not available because both of the copies of book 2 are in loan by member 3. So until now, have any questions? Okay, so let's move on. I think I'm done much part of it. And now let's say we want to add further constraint. Further constraint is that now in our model, book 1 was reserved by member 3, and book 2 and book, so both of the copies of book 2 is also reserved by member 3. So basically member 1 and member 2 don't have any book, but member 3 had all the books in our library, and we want that each member cannot have more than 2 loans, and each member cannot have same book. For like this member 3 has book 2 twice, and this member 3 also had 3 loans, so he cannot have more than 2 loans, and he cannot have duplicate books. So we want to also ensure that. So how we can ensure that in our model? So I am now going to slide 57 for the ones who are following online, and I copy the content from 57 for our class member. So we go to editor again, and now what I will do, I will replace this class member because this invariant or this constraint is about the members. So what it does, as you can see, it has previous attributes, name, and we have now 2 new properties, so loans and the books. So the loans property, it says that it cannot have multiple more than 2 loans, and it's calculated, it's also derived, and it's calculated in this invariant. So it called at most 2 loans. So the loans by this member, and basically the size of the loans by this member should be less than or equal to 2. And then there is another property that says that the same book cannot be reserved or loaned by a member twice. So and that one also derived, and this one also volatile. So this kind of properties will be always volatile, as you can see, but some of the properties you can also introduce, like not unique. So the books should be always unique, or the loans. So we are basically calculating this invariant called unique loans, and we are checking if this book that was loaned by a member is unique or not. So it will return some Boolean value. And now if we check the invariant for this member and go to our model instance. So until now we did not validate, but now if we validate, it will have 2 problems, or basically those 2 constraints will fail. So at most 2 loans by member failed, and also the unique loans failed. So the question is, what was the problem in our model for which our constraint, one of the constraint on member 3 failed? So can you identify those problem? Because there was no problem in the meta model or the model, but we had the problem in the modern instance. So member 3 had 3 loans, right? So the rule says that one member cannot have more than 2 loans. What we can do, maybe book 1 we can loan it to member 2, and if we save it, I think one of the problem will be gone. So now each member has maximum 2 reservations. Then we have also has this unique loan. Again, this member 3 still is having same copy of book 2. So for that one, either we can assign this book 2 to another member, or we can assign the member 3 if he wants to have 2 copies, 2 loans to book 1, let's say. And did we save it? Book 1 and book 2 by member 3, and then we'll have another problem, because we have only 1 copy of the book 1, but we have made loan 2 copies of the book 1, right? So let's see what new problem we have. Yeah, so now we have another problem of sufficient copies. To resolve this problem again, so what we can do, we can so the last one was book 2, and so maybe what we can do, we can assign book 1 to member 1 only, and then now we have member 1 with book 1 only. So book 1 has only 1 copy. Okay, so book 1 still have 2 copies. So what we can do, we can assign this book 1, this member 3 to book 2. But then we have another problem, is that we have the same copy of book 2 by member 3. So this one may be assigned to book member 2. So I think now all the problem will be resolved by our model, and this is another way of basically validating your model instance and the model. So how you are doing that? You are basically introducing constraint in your main model that will be evaluated in your instance models, and we do that for class book and also class member, and in that way you can also add other constraint for other classes as well. So as a part of your assignment, the RE assignment, you will also write at least a couple of constraints over the classes based on how you design your requirements, because you also need to come up with this kind of class diagrams. Let me show this one. Edit. Why it's not showing the class diagram? Okay, class diagram. So design. So for your assignment 1, you will pick up 1 requirement, and then you will also come up with kind of similar class diagrams, and on which you will write some constraint to show that your constraint are checked or ensured or validated during runtime or during design time. So I think that's what I wanted to show you, like how to write OCL constraint and how to validate them on your instance model. So do you have any question before we wrap up? I think also on slide, yeah, we have covered more or less everything. And there are some more online materials that you can look at, like this is the fourth one is about OCL, and there is also, I think, the Eclipse version that I used, and the best way to get through this is to use the modeling version of Eclipse, because that has all the modeling support. So anybody has questions in the Slack? I guess not. So did anybody on the Slack could follow my whole process, whole tutorial? I guess nobody could follow since nobody responded. So do you have any questions? So what I will do, I will, okay, so Jacob said he could. So what I will do, I will also put the whole, so the slides will be there. So some of the code, or basically all the codes, are on the slide. But I will also put the whole tutorial step by step in a PDF in online, so that you can play with in your home, and so that you can also get to know the OCL as part of your assignment. So if you don't have any questions, then maybe we can wrap up, and thank you for joining this lecture, and see you on Friday. Also Friday, bring your laptop as well, because we will have some more, so another tool that we want to play with for requirements management or requirements generation.
Excuse me?
Yeah.
Could you put up what the tool is we can install beforehand?
Yes, that's a good question. So let me see the name of the tool. So it's STS tool. So STS, I think, is this one. So if you go to this website, and then you have downloads. Oh, sorry. So get this tool and try to download. If you are using Mac, not only download the tool, but also I think you need to put it in the application folder. If you don't put it in the application folder, it will not work. And then maybe it will be easier to follow the tutorial if you get the tool and install before the lecture. So it's sts-tools.eu. So people online, so there was a question, what was the tool? What will be the tool that we will use on Friday? It is this tool. So if you can install it before coming to the lecture, it will be a good start, and we will spend less time on installing the tools. Any more questions? No? Then see you on Friday.